Hello everyone, I'm Dr. Shaik Ruksana Begam, working as Assistant Professor in the Department of Electrical and Electronics Engineering from Institute of Aeronautical Engineering, Hyderabad. Today I'm going to deliver a lecture on how to solve the problems on mesh analysis. So today's topic is about how to solve the problems on mesh analysis. So in the previous lecture, we have seen how to calculate the mesh currents by using mesh analysis. I have already mentioned mesh is a closed path which allows the flow of current. So I have already told what is the difference between loop and mesh. So if we recall the previous topic, I have already told what is the difference between mesh and loop. So loop is also which allows the flow of current or which shows the path to for the current to flow, and mesh is also a closed path which allows the flow of currents. It is a closed path which allows the flow of currents. So here if we see this diagram, here we are having two meshes and three loops. In the simple manner we can say a mesh first mesh can contain only one loop. So in the simple way we can say that a single mesh can contain only one loop and a loop can contain n number of meshes. So one mesh will contains only one loop. So one loop can have n number of meshes. So all the meshes will be loops, but all the loops will not be meshes. So this condition we have to remember. So in the previous lecture, we also have discussed what are the steps to solve mesh analysis, and even we have solved two problems regarding mesh analysis. Once again, I'll recall the steps. So these are few steps to solve mesh analysis. So first step, we have to identify loops or meshes in a circuit and label mesh currents to n meshes. So if we are having n meshes, we have to label the loops first. First we have to identify the loops or meshes in the circuit, and then we have to label it as I1, I2, I3, and if we are having n number of meshes till In, we have to label the meshes. So in the second step, we have to apply KVL to each mesh with the corresponding mesh current to generate n equations. So by using the KVL, we have to calculate the currents in the meshes, and then we have to solve the resulting simultaneous linear equations for the unknown mesh currents using Cramer's rule. So in the previous video, I have told how to calculate the currents directly by using scientific calculator. So in the scientific calculator, we can directly substitute the equations of mesh currents, and we can calculate if there are n number of meshes, we can calculate n number of currents from that scientific calculator, or else we have to use this Cramer's rule to calculate the currents in the mesh. So already have shown you in the last video, this is the scientific calculator. In this we have to go for mode setup, and then we have to select the option 5. So option 5 will be of equation. So depending upon the meshes we are having. So if we are having two meshes, we have to select this first option, and then we have to substitute the values in this equation, and we have to find the values of I1 and I2. If we are having three meshes, so we have to select the option 2, and we have to calculate I1, I2, and then of I3. So by using this scientific calculator, we can directly substitute the values of meshes, and then we can easily calculate the values of currents. So moving to the next example problem. In this, the question is, in the circuit shown in the figure, determine the mesh currents I1, I2, I3. So in the question itself, they have mentioned this problem consisting of three meshes, which is named as I1, I2 and I3. So if we see this circuit, in this circuit we are having three meshes. One is of BCAE, and second mesh is of CFDG, and third mesh will be of DGEH. So this is mesh 1, mesh 2 and mesh 3. So these three meshes are named with I1, I2 and I3. So now we have to calculate the currents in these three meshes. So to calculate the three meshes, first step is to identify the loops in the circuit. So here there are three loops which is denoted with I1, I2 and I3. So in the next step we have to apply KVL and we have to write the mesh equations of each mesh, and then we have to substitute the mesh equations in the scientific calculator, or by using Cramer's rule we can calculate the currents in mesh 1, mesh 2 and mesh 3. So for the next step, first we have to write the equations in the each mesh. So here I have taken the direction as clockwise. First we have to remember, if in the first mesh we are taking the direction in clockwise, then we have to consider all the other meshes also in the same direction. For example, here there are three meshes. So for the first mesh, I am considering it as clockwise direction. So the current is flowing from negative to positive. So in the second and third mesh also have to consider the same direction. So we should not take for the first mesh, as we are considering clockwise direction, and for the second mesh we should not consider anti-clockwise direction. So if we are considering clockwise direction for the first mesh, for the second and third also we have to consider the same direction. So here if we take the first mesh, the current is flowing in the clockwise direction. So it is flowing from negative to positive. So as if it is flowing from negative to positive, the equation will be of -7, and the current flowing in the 1 ohm resistance is connected in between mesh 1 and mesh 2. So as with respect to first mesh, I am calculating for the resistance 1 ohm. So I am taking it as 1 into I1 minus I2. So as if I am considering for the I2 mesh, so I will be taking off I2 minus I1. As if I am considering for the first mesh, I am taking it as I1 minus I2. So and then moving to the next element here, plus 6 volt source is connected for the first mesh in between mesh 1 and mesh 3. So as if the current is flowing in the clockwise direction, the direction will be the current is flowing from positive to negative. So it will be taken as +6. And then the 2 ohms element is connected in between I3 and I1. As if I am considering for the first mesh, I am taking it as 2 of I1 minus I2. So as for which mesh we are calculating, that mesh should be considered in the first position, and then we have to go for the other. So as if I am considering for the first mesh, I am taking it as I1 minus I3. So if I am taking for the third mesh, it will be of I3 minus I1 will be equals to 0. 3 of I1 minus 1 I2 minus 2 I3 so -7 plus 6 will be equals to 0. So from this we can write the first equation as I1 minus 1 I2 minus 2 I3 minus 1 will be equals to 0. Or we can also write it as 3 I1 minus 1 I2 minus 2 I3 equals to 1. This will be of equation 1. So here is the equation 1. So now we have to write the equation for second mesh. So same, the direction of the second mesh is also taken in the clockwise direction. So the second equation can be written as, so first I am writing the equation here, 3I1 minus 1I2 minus 2I3 will be equal to 1. This will be equation 1. So the second equation for the circuit can be written as, So for the second mesh, so the direction is taken as clockwise direction. So I'm taking it as 1 off. As if I'm considering for the second mesh, the equation can be written as I2 minus I1. And here again the 2 ohms element is connected to the second mesh only. So I'm taking it as 2I2. And if we see here, the 3 ohms resistance is connected in between I2 and I3. So now we are considering with respect to I2. So the equation can be written as 3 of I2 minus I3 will be equals to 0. So now I am taking the values of I1, I2 and I3. It will be of 1 I1, 1 plus 2, 3, 3 plus 6. So it will be of 6 I2 and minus 3I3 will be equals to 0. So this will be of second equation. Now I am writing it the second equation. So minus 1 I1 plus 6 I2 minus 3I3 will be equals to 0. So this will be of second equation. So now we have calculated for the first mesh and second mesh. Now we have to consider the third mesh. So the third mesh equation also can be written as, so it is also taken in the clockwise direction. So we have to write it as, so the 2 ohms element first I am considering, it is connected in between I1 and I3. So I'm taking it as, with respect to I3 I'm calculating. So I'm taking the I3 first. I3 minus I1 plus 6 plus 3 of I3 minus I2 plus 1 I3 will be equals to 0. So now I'm calculating the terms I1, I2, I3. So here I1 will be of minus 2 I1, and if we take I2 it will be of minus 3 I2. 2 plus 3 is 8. Sorry. 2 plus 3, 5, 6. So plus 6 I3 minus 6. So this will be of equation 3. So now I am writing the equation 3 here. 2 I1 minus 3 I2 plus 6 I3 will be equals to minus 6. So this will be considered under equation 3. So these are the three equations which we have got from these three meshes. So the first equation is of 3I1 minus 1I2 minus 2I3 is equals to 1. And this is the second equation, and this is the third equation. So now we have to substitute all these three equations in the scientific calculator. For that we have to select the option 2. So as if we are having three meshes, we have to substitute all these three equation values and we have to calculate the values of I1, I2 and I3. So after solving this equations in the scientific calculator, we'll get the values of I1 and I2 and I3 as 3 amperes, 2 amperes and 3 amperes. So these are the values of I1, I2 and I3. So moving to the next problem. So in the circuit shown in figure 2, determine the all branch currents by mesh current analysis. So here we can see mesh 1, 2, 3. So first we have to see the circuit. So as the current source is connected in parallel with the resistance, we have to convert this current source into a single voltage source in series with resistance. So in the source transformation technique, by using source transformation technique, we have to solve this circuit. So if there is any current source in parallel with resistance, we have to convert that element into a voltage source in series with a resistance. So this can be converted by using the formula V is equals to IR. So if we want to convert current and resistance into voltage, so we have to take the current is of 10 amperes and the resistance which is connected in parallel with the current source is taken as 10 amperes. So the voltage across, so the voltage source will be of 100 volts. So Here we have to redraw the circuit with a single voltage source in series with a resistance, which is of this resistance we have to take as it is. It will be of 10 ohms, and then again the 5 ohms is again, all rest of all the circuit will be connected in the same way. So 20, 5, 5, and here is a source 30, 5, 5 ohms plus or minus of 100. So here the source voltage will also be of plus or minus of 100 volts. So in this way we have to redraw the circuit after reducing this current source and resistance into a single voltage source in series with a resistance. Now these two resistances are connected in series. So we can sum these two resistance so that we'll get the value of the resistance will be of 15 ohms. So again here I am redrawing the circuit. So after reducing this current source and resistance into a single voltage source in series with a resistance, the circuit can be again redrawn in this way. So as these two resistances are connected in series, I am adding these two resistances. The value of this resistance will be of 15 ohms, and the rest of the circuit is connected in the same way. So now if we see this circuit here, there are three meshes. So this is one mesh which is taken as I1, and here is the mesh 2 which will be taken as I2, and here is the mesh 3, so which is denoted with I3. So now we have to calculate the mesh currents which is of I1, I2 and I3. So by using mesh analysis, first we have identified how many meshes are there in the circuit. We have identified that there are three meshes in this circuit, and we have named these meshes as I1, I2 and I3. Now we have to calculate currents of I1, I2 and I3 by using mesh analysis, and by applying KVL we have to write the equations first. So I have already told, if the first mesh is taken as clockwise direction, the other rest of the meshes also we have to consider in the same direction. So this is also taken in the same direction, which is of I1, I2 and I3 are connected in taken the same direction, which is denoted with clockwise direction. So for the first mesh we have to write the equation. So as if the current is flowing from negative to positive, it can be written as minus 100, and this element is connected, and across first mesh the current flowing in the first element will be taken as plus 5I1, and this, if we consider the 20 ohms element, this is connected in between I1 and I2. So as we are considering for the mesh 1, we have to consider I1 first, so it will be taken as plus 20 I1 minus I2 equals to 0. So now we are going to write the equation for the second mesh. So here it will be, first 20 is connected in between mesh 1 and mesh 2. As if we are considering for the mesh 2, should be taken as I2 minus I1, and then plus 5I2. And again, if we consider the 30 ohms resistance, it is connected in between I3 and I2. So first, as if we are considering for the second mesh, we have to write the equation as I2 minus I3 will be equals to 0. So, and third equation for the third mesh will be written in the same way. So, as if we are considering for the third mesh, it will be taken as I3 minus I2, and 5 ohms is connected only for I3. And then as if the direction is flowing from positive to negative, it is denoted with plus 100 will be equals to 0. Now, if we take out the values of I1, I2, I3 for the each equation, the equations can be written in this way. So the first equation will be written as, so 5 and 20. So this is 15. 15 plus 20 will be taken as 35. So 35 I1 minus 20 I2 is equals to 100. This will be of equation 1. So coming to the next equation, here the second equation will be written as minus 20 I1 plus 20 plus 5, 25. 55 I2 minus 30 I3 will be equals to 0. This will be taken as second equation. And if we consider the third equation, it will be written as minus 30 I2 plus 35 I3 is equals to minus 100. This will be considered as equation 3. So if we see the equation 1 and 3, here we are not having the values of I3 and here we are not having the value of I1. So as if we are not having the value of I3 and I1, we have to assume this as, so I1 current will be becoming 0. So here we have to take a 0 I1. So in the same way, here I3 current is taken in the way 0 I3. So now we have to substitute all these three equations in the scientific calculator. From that we have to calculate the values of I1 and I2 and I3. So by calculating or by substituting all the three equations, we'll get the values of I1, I2 and I3 as 9428 minus 1.6 and minus 4.28 amperes. Yes. After substituting this equations in the scientific calculator, we'll get the equations of values of I1 and I2 and I3 as 1.9428 amperes per I1 and I2 is minus 1.6 amperes and I3 will be of minus 4.228 amperes. So in this way we have to calculate if there is any current source connected in parallel with a resistance. First, to make the system or make the circuit easy, we have to convert that current source which is connected in parallel with the resistance into a single voltage source which will be connected in series with one resistance. So by converting this, by this source transformation technique, we can make the circuit easy to calculate the currents. So first we have, if we see any current source is connected in parallel with a resistance, to make the circuit easy, first we have to convert the current source which is connected in parallel with the resistance into a single voltage source which is connected in series with the resistance. So first we have to convert this circuit and then we have to identify the meshes. So after conversion, we have to identify the meshes and we have to denote the mesh currents for each mesh and then we have to calculate the currents by using KVL. So first we have to write the equations of first, second and third meshes and then from that we have to take out the values of I1, I2 and I3. As if there is no current I3 flowing in the first loop, so we have to assume I3 as 0. So as if in the third loop there is no I1 current flowing, so I1 will be assumed as 0. So while substituting in the calculators, we have to assume I1 and I3 values for the first and third equations will be of 0. So by substituting these values, we'll get the current values. So the current flowing in the first mesh will be taken as 1.94228 amperes, and the second mesh current will be of minus 1.6, as if the direction of the current is reverse. If we are getting the value in minus, then we have to assume that the current is flowing in this opposite direction. So the I3 current is also in minus, so here also we have to take the current is flowing in opposite direction. The value of I3 will be taken as 4.228 amperes. So if we move for this next example, if you see this question, in the circuit shown in the figure, determine all branch currents by mesh current analysis. Here also, if we see this circuit, so in the previous circuit, I have told if there is any current source connected in parallel with the resistance, first we have to convert that into a single voltage source, and the resistance will be same. That should be connected in series. So if you see this circuit, here is one voltage source and the resistance is connected in series, and here is current source connected across these two meshes. So if we see such type of problems, first we have to convert this voltage source and resistance into a single current source parallel with the resistance. So if we convert this single source in parallel with the resistance by using the formula I is equals to V by R. So as all we all know, V is equals to IR. So as if we are converting the current source, sorry, voltage source and resistance into a current. So we are using the formula I is equals to V by R. So by substituting the values of V and R, it will be of 100 by 10. So the value will be of 10 amperes. So the value of the current is taken as 10 amperes. So now we have to redraw this circuit. That means we have to connect one current source in parallel with the same circuit, and we should also connect this resistance in parallel with that current source. So if I redraw this circuit, so after converting this voltage source and resistance into a current source parallel with a resistance, the circuit will be redrawn in this way. So the next part of the circuit will be as it is. The first part of this voltage source and resistance will be converted into a current source and parallel with the resistance. Now if we see, if both the directions of the currents or sources are in the same direction, so if the current sources are flowing in the same direction, we have to add both the sources. So we have to remember, if the current sources with the same direction are connected in parallel, we have to add. So if the two current sources are connected in the same directions, we have to add. If one of the sources connected in the opposite direction, then we have to subtract. So as if we see this circuit, the both the directions of the current is connected in the same direction. So we have to add the both of the sources. So if we add both of the sources, then we'll get 10 plus 10 will be equal to 20 amperes. So 20 amperes, after calculating both of the sources, we have to redraw the circuit again. Again the circuit will be redrawn as, so this element will be removed. So again it will be becoming 20 amperes. So as if I have added these two sources, so the value of the current source will become 20 amperes. So if we see the previous problem, we have converted, if a current source is connected in parallel with a resistance, we have converted that circuit into a single voltage source which is connected in series with a resistance. So now we have to convert this current source and resistance into a single voltage source in series with a resistance. So for this we have to use the formula V is equals to IR. The value of I will be taken as 20 and the resistance value is of 10. So the value of V will be equals to, so the value of V will be taken as 200 volts. Now again we have to redraw this circuit. So the circuit can be redrawn in this way. So now I am removing this part of the circuit. So again I am connecting the resistance which is in series with the source. The value of the source will be taken as plus and minus of 200 volts. So after reducing this network by using source transformation technique, now the final circuit is formed. So from this we have to calculate, so first we have to find the mesh currents. So first we have to see how many meshes are there and we have to denote the mesh currents for the each mesh, and then by applying KVL we have to take out the equations from the each mesh, and then from that we have to calculate the values of I1, I2 and I3. So first here if we see this circuit, here there are the three meshes which will be denoted with I1, I2 and of I3. So these are the three meshes which we have denoted, and then we have to write the equations of each mesh by using KVL. So as if we are taking the directions of these currents as clockwise direction, the equations of each mesh can be written as, first the current is flowing from negative to positive. For that we have to take it as 200 minus 200 plus 10 I1, and then the 10 ohms are connected in between I2 and I1. As if we are considering for the first mesh, we have to take it as 10 of I1 minus I2, and moving to the next element, here the 10 ohms resistance is connected in between I3 and I1. So we have to take it as 10 of I1 minus I3 will be equals to 0. So from this we have to take out the equations of, take out the values of I1, I2 and I3. So which forms equation 1. So here 10 is connected for I1. Again 10 ohms is connected for I1. So here 3 tens, then we can write it as 30 I1 minus, so plus of minus which will be taken as minus 10 of I2 minus, so plus of minus will be taken as minus 10 of I3 will be equals to, equal to 200. So this will form equation 1. So this is the equation for the first mesh. And then if we move for the second mesh, it will be taken as plus, no need of mentioning any plus. So 10 of I1 and I2 is connected. As if we are considering for the mesh 2, it will be taken as I2 minus I1. And for the next element, it will be taken as 10 of I2. And for the third element, it is connected in between I2 and I3. So it will be considered as 10 of I2 minus I3 will be equals to 0. So from this we have to take out the values of I1, I2 and I3. So plus of minus will be of minus 10 I1, 10, so 3 times plus 30 I2 minus 10 I3 will be equals to 0. This will be of equation 2. So now we have calculated for the equation 1 and 2. Now we have to calculate the equation for the third mesh. So if we consider third mesh, it is also taken in clockwise direction. Again the values will be taken as 10 of, so it is connected in between I3 and I1. So as if we are calculating for the third mesh, we have to take it as I3 minus I1, and then if we move for the next element, it is connected in between I2 and I3. As if we are considering for the third mesh, we have to take I3 minus I2, and this 24 ohms is connected only for mesh I3. So it will be taken as 24 I3 will be equals to 0. From this we have to take out the values of I1 and I2 and I3. So it will be of minus 10 I1 plus, sorry, minus 10 I2 44 I3 will be equals to 0. This will form equation 3. So now we have got 3 equation from 3 meshes. Mesh 1, mesh 2, mesh 3. So we have got the 3 equations. From this we have to calculate the values of I1, I2 and I3. So by substituting these values in the scientific calculator by using equation calculator, so we have to substitute all the values of I1, I2 and I3. So from that we can get the values of I1, I2 and I3. So after substituting the 3 equation values in the scientific calculator, we'll get the values of I1, I2 and I3 as. So the first current flowing, I1 current flowing in the first mesh will be of 8.997 amperes, and the current flowing in the second mesh will be of 3.97 amperes, and the third current flowing in the mesh 3, which is denoted with I3, will be of 2.941 amperes. So in this way we have to calculate the mesh currents by using mesh analysis. Yeah, that's it for today's topic. We'll meet in the next session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.